Trapezoidal Rule. Section 6.5. Shh, guys. So there's one more numerical method we're going to learn. So we've learned right endpoints. We've learned left endpoints. We've learned midpoint. Now we're learning the last one, which is trapezoidal rule. Okay, so it's an easy approximation thing. You're going to have a table. You're going to be able to plug numbers in. You'll like this. It's not bad. Okay. There is another one called Simpson's rule, but that's going to be on the DC exam, so we're not going to talk about it. So first, let's review the midpoint rule. So the midpoint rule, remember if I gave you like the integral of x squared plus 1, you would think about what x squared plus 1 looks like. And you'd go from 0 to 1. And I said with n equals 4. So basically, you're going to divide it into 4 pieces. Okay, a lot of times what I did for you guys is I drew like a really big number line to help you, because it got a little bit confusing. Okay, and I wrote those numbers in. So 0.25, 0.5, 0.75. Are those the numbers that I'm plugging into my function? No, because I'm using the midpoint rule, right? If I use the midpoint rule, what numbers am I actually going to use?
Oh, the ones in between.
0.125. What's this one?
7.
Yeah. 875? Is it 875? Okay, 875. Okay. Thank you. You allowed me to not think on that. Hopefully those are correct. All right, so as we find these values, we're going to plug these into our function, right? And we're still using the entire width of the interval is 0.25, right? But these rectangles are basically going to go up, and the midpoint is going to be the height. So it's going to like have a little bit above, a little bit below. And I like this approximation method because it seems a lot more accurate to me than the right endpoint or left endpoint. Okay, it's kind of finding a little bit like the average right away. Okay, so we're going to go ahead and do that. So we're going to plug in those values into the function. So I might just do it all on my calculator. So 0.125 squared plus 1 plus 0.375 squared plus 1. You could also find them on the table, but I didn't want to have to carry over all these decimals. 0.625 squared plus 1 and 0.875 squared plus 1. Right, so when I do that, did you guys do it? So I'm going to say it's 5. Oh, I forgot to multiply by my width of my interval, times 0.25. So it's like 5.3125, but then divided by 4, because the width of the interval is 0.25. So you could say times 0.25 if you want. So you should get 1.328. Did you guys get that? Those of you that tried to go along with me? Yeah. Okay, so that was the midpoint rule. Okay, here's what the trapezoidal rule is going to do. So the midpoint rule, I thought was pretty close. It's pretty accurate. It's not bad. The trapezoidal rule is pretty cool. I like it. I get very excited, and then no one else does, and Bob pretends that he's excited, and I don't think he is. Okay, so if I have the area from A to B, let's say I'm breaking it into different intervals. Okay, here's what's going to happen. You're going to take your endpoint, and you're going to connect it with the other endpoint. So it's kind of a combination of right and left endpoints. And when you do that, it's going to create these trapezoids. Amazing. I should have drawn it more exaggerated so you can see. Oops. Okay, so each of these shapes are trapezoids. They're just kind of on their side. Do you guys see it? Like the height of the trapezoid is here. And this is like B1 and B2 for your trapezoid. Let me draw it a little bit more exaggerated so you can see. Are you guys seeing it on your paper? No? Let's say I go down, and then I go back up really high. That will work. Okay, here's one of the trapezoids. Do you see it? This is like the height of the trapezoid. This is like B1. This is B2. It's just on its side. So remember, if you find the area of the trapezoid, it's going to be 1/2 h times B1 plus B2. So h is the distance between your two parallel segments, and then B1 and B2 are the ones that are different sizes. Okay, so that's what we're going to do. We're going to find the area of each of those trapezoids. Okay, so here's the formula. It looks very strange. You will probably never use this formula on the AP test because they never make it so that you have a constant like width for your trapezoid. They're just so mean, those AP test makers. I know. It looks confusing, doesn't it, when you see it? You're like, oh my gosh. So basically what's happening is when they talk about delta x, that's your height. That's like the height of the trapezoid. This is the formula when all of those heights are exactly the same. Like maybe you have 1-inch segments or something. You see what I'm saying? Like 1 unit between each one. What's the 1/2 come from? Like, see how you have a 2 down at the bottom? Yeah, it's from all of them have like 1/2 h, 1/2 h, 1/2 h. All of the trapezoids that you're adding together will all have that. So you just pull it all to the front. So that's what this whole thing is. It's the delta x, the h, divided by 2. Okay, that's what the formula is. Okay, and then why do I have f of x sub 0 and then I have 2 of f of x sub 1? Yeah? Do you get it?
The first trapezoid, the first side of the first trapezoid is the only one that's single.
And there's one more. And the very last one. Good. Look at you. You guys are good. Yeah, so see you have all these like little trapezoids that you're adding up. And this is the height of the first one. So we call it f of x sub 0, the first marking. Okay, and then if this is x1, then this is the height of the second one, x sub 1. F of x sub 1. All right, so for this first trapezoid, the one I'm shading in green, you're using the B1 is f of x sub 0. The B2 is f of x sub 1, right? Then the next one that you use, so the one I'm drawing in blue, it uses f of x sub 1 and f of x sub 2. Do you guys see this? So the f of x sub 1 is used twice because it's used with the first trapezoid and with the second trapezoid. The only ones that are used a single time are the first one and the last one. So this one is x sub n, you know, if you do dot dot dot, f of x sub n. Okay, that's where the formula's coming from. Okay, so compute the trapezoidal rule approximation with n equals 4 for the integral from 0 to 1 of 3x squared dx. Okay, so again, we'll kind of sketch it out to help us. So I have 3x squared. I'm going from 0 to 1. And I have n equals 4. So again, I'm dividing it into tiny little subregions. Okay, so the first one that I have is actually just a triangle. And then the second one is a trapezoid. The third one is a trapezoid. And the fourth one is a trapezoid. Do you guys see how it looks almost exactly like that curve? It's really close to it. It's a good approximation. Yeah? All right, so this first one that I said is a triangle. Do you guys see why it's a triangle? The B1 for it is just 0. It's at a height of 0. So it's kind of like you do 1/2. H is 0.25, right? It's the width of the interval. Right, all of these are 0.25. And then you're going to have 0 plus whatever this height is. So let's find each of these heights here. So this first one was 0. Someone's getting down in Spanish class. I feel like I need to go over there. Have a siesta. Siesta? That's not right. Fiesta. Siesta's nap. I need a nap. That's what I need to do. Let's see. So 0, 0.25, 0.5.
Wait, how are you finding the heights? You plugging in the width?
I'm just plugging in like 0.25, 0.5, 0.75, and 1.
Into the original.
Into the original, yeah. So when I do that, I get 0.1875, 0.75, 1.6875, and 3. Okay, so for this first trapezoid, I'm using the term trapezoid lightly because it's really a triangle. Do you guys all see that's a triangle? The B1 was 0, and the B2 was 0.1875. Okay, that's why it's creating the triangle equation, 1/2 base times height. Okay, and then plus, I'm still going to have my 1/2 times 0.25, but now my height is 0.1875, and my other, sorry, I said height, my B1 is 0.1875, and my B2 is 0.75. Okay, so that was this one. Now I'm ready for the next one. Right? It's going to still have the 1/2, and the height is still 0.25. And it's going to use the 0.75 plus the 1.6875. Okay, and then the last one is here, and it's going to use the 1/2 times 0.25, and then it's going to use 1.6875 plus 3. So if you kind of factor out all of the things in common, my 1/2 times 0.25, do you see what Blake was talking about? You have 0 plus, you end up having 2 of the 0.1875s, because you have it here and you have it here. And then you have 2 of the 1.6875s. And you have, oh, I skipped one, didn't I? 0.75s. 2 of the 0.75s, and 2 of the 1.6875s, and then only 1 of the 3s. That's where the formula comes from. So it's not hard to memorize. It's not bad. Okay, so let me find that. So 2 times times 0.1875 plus 2 times 0.75 plus, I guess I didn't have to do all the 2 times 1.6875 plus 3. So I get 1/2 times 0.25 times 8.25. So now I'm going to do times 1/2 times 0.25, or you could simplify, right? So you should get 1.031 if I round to 3 decimals. It's really 1.03125. Maybe I'll write that and then do approximately. Does this make sense? Trapezoidal rule? It's not that bad. Okay, so what I was saying is the AP test never gives you those like common widths. So the H for each of your trapezoids is never the same. Like what they will do is they'll give you a chart probably, and they'll have like 3, and then this one will be 1, and then this one will be 5, and you're just finding it from there. Do you see what I'm saying? So you really should think about the individual trapezoids, the area of each individual trapezoid. Okay, so that's what this one is. This one, I guess I did give you a common. I gave you like 10 feet for the width. Okay, so we're going to estimate the area with n equals 6. 6 of them. Ben, are you paying attention, Lauren? All right, so how many? I have 12 listed there. So how am I going to do this? There is a solution.
So it would be 1/2 times n.
Well, it's going to be 1/2 times, it's going to be 20. Because see how you go from 0 to 120? If you're doing 6 subintervals and you see how they're all evenly spaced, you're going to have to go from 0 to 20. So if I'm doing my trapezoidal rule, I'm actually using 0, 20, 40, 60, 80, 100, and 120. And it looks deceiving because you're like, but there's 7 numbers there. Those 7 numbers create 6 trapezoids. So the first few times you do this, if you want to sketch it out, you can do that. If you feel like you can do it without sketching it out, that is fine. So some of you, I know Blake is going to be like all over not sketching it out. He's going to be like, I got this. All right, and then some of you are very visual and you're going to be like Lydia, very visual, art person. She's going to want to sketch it out. That's fine. I sketched it out when I was in high school. I had to see it. Actually, we didn't do these when I was in high school because my teacher never mentioned trapezoidal rule. And then I was like, oh, okay. When you have to teach it and you're like, okay, never learned this. Cool. But it is on the test all the time. So if I have 0 to 20, 40, 60, 80, 100, 120. What I just do is I do a very rough sketch. So you can do the height of 56, just write 56 above it. It does not have to be perfect. It does not have to be drawn to scale or anything like that. Oops, I'm off one. Where did I go? Did I do 258s? Okay. Oh, I didn't start on 0. Oh, rough. Zach, you get a point. You just let me go with it, man. Okay, so we have this. Okay, the reason I recommend sketching it out is because then you can clearly see the trapezoids as you sketch it out, you know? It makes it really easy. I'm very speedy. Do you like how quickly I draw that in? We got a lot to do. This is why I type up those 200 hand types pages of love, right? We'll go quickly. All right, so here we go. So these are all a common interval, like a common height. Like this is the height of the trapezoid, right? And your height is 20. So what I'm going to do is I'm just going to pull out the 1/2 and I'm going to pull out the 20 because all of them would have that, right? And the first trapezoid is going to be this height, 56, plus this height, which is 58. And then the next trapezoid is going to be 58 and 58. And then the next one's going to be 58 and 62. And then the next one's going to be 62 and 52. And then the next one's going to be 52 and 40. And then the last one's going to be 40 and 22. Did you get it? So you can do the 2 times thing if you really want to. I think it's almost just as fast just to type it in like it is. Except for all those 58s. I'm going to do 58 times 4. Ooh. All right, 62 plus 62 plus 52 plus 52 plus 40 plus 40. And you could add some things together as you're going. So I have 1/2 times 20 times, did you guys get 618? So 1/2 times 20 is going to be 10. So I get 10 times 618, 6180. That's it. So what does this mean? It says the table gives the measurement in feet of the width of a plot of land at 10-foot intervals. So we're going to have feet by feet, right? So we're going to get square feet. So it's like the area of that land. All right, so I said to do it both with trapezoidal rule and with midpoint rule. Oh, that's the worst, isn't it? That's why you had 120. That's why you had 12 listings. Think about the midpoint rule, guys. Which one are you going to use now? These ones. Right? You're using the ones in the middle. What's the width for each one? It's 20. So you're going to have 20 times 54 plus 20 times 62 plus 20 times 58. You could also pull out the 20. Plus 20 times 56 plus 20 times 48 plus 20 times 32. So 54 plus 62 plus 58 plus 56 plus 48 plus 32, and then multiply it all by 20. Pretty close. So both were pretty close to each other in the end, right? Yeah, both good approximations. That was not that bad. You guys were all like, oh, we have to do another. It took like 30 seconds. All right, so here's the type that they would definitely give you on the AP test. So see if you can do it. I'll give you a second. All right, so here we go. So suppose we didn't have a common width for our intervals as in number 2. Could you still compute the area of the plot with measurements using the trapezoidal rule with n equals 4? Okay, so if we have n equals 4, again, if you need to sketch this out, go for it. I am not judging you. If it takes you less time, if you draw a sketch, that is fine. It doesn't have to be perfect. 25, 50, 30, 22, and 10. But if it helps you visualize these different trapezoids, then, I mean, it's worth the extra 20 seconds it took to sketch that, right? So we sketch it. So we have 1/2. The first height of our trapezoid is 5. It is this distance right here. The B1 and B2 are 25 and 50. Okay, then we have 1/2, and now the height is 7. And the B1 and B2 are 50 and 30. And then we have our 1/2, and our height is 2. And the B1 and B2 are 30 and 22. And then we have 1/2 times 6, and we have 22 and 10. That's all it is. You can pull the 1/2 out of each one if you want. Yeah, is that what you're saying? And you can kind of add as you're going, right? 25 plus 50, you know, is 75, right? And then 7 times 80 plus 2 times 52 plus 6 times 32. And then times the 1/2 at the very end. What did you guys get?
650.
Yep, and that would be another like square feet. I did not use anywhere close to the numbers we had before, so you creeped me out, Mr. Napier. I looked up and he was here. Woo! All right. Was that the last one?
So
Yeah.
there's like 50 trapezoids per one,
If there's what?
like 50 trapezoids.
There are never going to be 50 trapezoids. The most you'll have is like 10. And they'll have like a little chart. You'll be all right. You can do this.